So my name is Tristan Chiappisi. I really want to say, before I even start here, thank you all so much for being here. It means the world to me that I can do this work and speak at these conferences. When I was a little kid, I went to a Microsoft conference. I was homeschooled, and I remember seeing guys up there talking and doing this stuff, and I was like, oh my God, this is my dream. It's like the nerdiest thing ever. I was 15 years old with my brother. He ran a small company, and I remember seeing people speak like this, and it was the coolest thing in the world to me. And now that I can do this today, it means the world to me. So thank you all so much for being here. And thank you to Stir Trek as well. So who am I? And we're going to be talking about SQL. I'll go into that in a second. But who am I? I'm Tristan Chiappisi. I've been in this field for 25 years, not just specifically in data, but about 20 years into data itself. And it's pretty much been my lifeblood for everything I do. I work for a company called Cetera Financial Services, and I am a principal data architect, and I work on AI strategy as well. So those are my two roles, and we're going to be talking today about SQL and how to tune queries. The theory behind this talk, and I've given this talk before, is we have one bad query and 10 problems with it. So we're going to go ahead and systematically go through all of the problems with this one query, and by the end, hopefully we'll have a good query that runs pretty fast. So this thing now takes 6 seconds. We're going to get it down to 47 milliseconds, which is pretty incredible. I don't do PowerPoints. I only make websites when I do presentations, so you can all go to this after, now, whatever. It's pretty crappy from a mobile perspective, so sorry. But SQLcaffeine.com, if you want to go and see it, I don't make money on it or anything. This is just for side personal projects. I only do it for conferences. So if you want to go check it out, I think it's pretty cool. So let's go ahead and just dive right in, because we only have 45 minutes. And unfortunately, I have to sit behind this podium the whole time because I have to click through it. So here's the schema. We have a basic customer database. I have customers, I have customer addresses, categories, et cetera, et cetera, et cetera. We've all probably seen a database similar to this. Maybe not customers, maybe it's just people, it's HR data, something like that. But they're all pretty similar when it comes to it. You have a main entity like a person, and you have another entity like orders and all the receipts around that, and all the the metadata around those things. The funny thing about SQL and databases is everything runs fast nowadays on modern hardware, regardless of how bad your queries are. It doesn't matter. So until a certain point. And when I first started my career, there's a concept called a VLDB, which is a very large database. It used to be 500 gigs. Now it's more encroaching about the terabyte size or larger. Those are considered the VLDBs. And that distinction is important because when you talk to folks at Microsoft or you talk to folks that work on the engines themselves, a lot of the testing is done on the bell curve of the data, right? How big it is. So once it starts encroaching in the VLDB, they don't do as much testing. So you will see that queries aren't as performant once you get to a larger sense, right? So you get to 500 gigs to a terabyte, and your queries just start acting weird. One day they're great, and then the next day they're really, really slow, and you don't know why, and your boss is calling you up saying, what's going on? Has anybody had that scenario before? You have a great query, works awesome, one day it goes bad. That's because in the background, there's a lot of systems. When you actually execute a query, it doesn't just execute the query. There's an entire set of stages it follows, just like AI today. Like when you pass in something to an LLM, there's a bunch of different stages. Queries have always been this way, where it has a syntax checker, it has a plan optimizer, it has all these other layers, and every query has this thing called an execution plan. And that's essentially the first time you run it, SQL, that doesn't matter the engine, SQL Server, Postgres, anything will go ahead and make a plan for that, for the most part. And it'll say, well, generally, based on the statistics and the data I know about this database, it's 500 gigs right now, this table has 100,000 records, et cetera, I'm going to do a scan on this because it's very small, I'm going to do a seek on this, I'm going to do all these different operators. The problem is if that database grows or that table grows unexpectedly, it will then flip a flag to say, hey, rebuild that plan. And sometimes, based on the query that executed at the time that the plan was rebuilt, it can go to crap. It can go really bad. And then it can be an unperformant query. And then it's kind of stuck there until you reboot the server, you do a recompile, you do some other things, or you change the code, it will kind of enforce one of those. So I'm sure you've asked the DBA, hey, it's running slow, they do some magic and it works good. It's most likely because it has rebuilt the plan, or they rebuilt statistics and then rebuilt the plan, things like that. So we're going to go into our bad query. I hope you can see it. We have 10 problems with this one query right now. So we're just going to start diving right into it. So the first problem is a select star. Does anybody use select stars in their queries here? I'll tell you why you shouldn't do that. So, if you look here, this is what you should be doing. You should be explicitly calling out the things that you need for many different reasons, right? You're passing data over the wire, you're causing extra scans and everything, but the main reason is because of this. If you look here, we're doing a select star against this query that we have. It's returning back 23 columns, most of which we don't need. We only need 7 of these, right? I need an order ID, a total amount, et cetera, et cetera, et cetera. Look how much data I'm passing back for 10,000 rows. I'm passing back 1.5 gigs of data back to the client over the wire, and then I'm throwing most of it out. Now, if I do it properly and I just pull back what I need, I'm pulling back 3 meg for 100,000 records. So it's really clear that a select star can burn you. Now, in this case, we have a blob, which you probably, it's debatable if you should or have or not. You have this, you have all these other bad things, right, that can add up to it. But this is one of the most common things I see, especially within CTEs, which is a common table expression, or just in general. Sometimes also, if you're using things like Entity Framework or Hibernate, it can do these things too. It just selects all the columns. It doesn't do a select star, it just selects everything. And it's pretty bad. So that's number one thing we're going to try to solve here. So we're going to go back over here. We're going to fix that. So now my query is fixed. Not really. So I'm a bit faster. I went from 600 milliseconds down to 509, or 5,900. The second one is sargeable. Does anybody know what sargeable means? It's a funny term. Usually one person does. It's search engine argumentable. And when I was talking about earlier regarding the engines that the query has to go through whenever you execute it, it has to do what's called search engine argumentable. And that means that it can use particular indexes. It can use different operators based on the state of the data that it knows. If it's not search engine argumentable, it essentially does a scan. It just says, oh, I don't know what to do. I need to scan this entire thing. So if you look over here, you got a before and after. The general consensus, or the general knowledge I'll tell you here is, if you see a function on the left side of the predicate, a predicate is basically a where statement or an and statement. Each one of those is called a predicate. If you see a function on the left side, it's most likely not sargeable, and any indexing strategy you ever use will just go to trash. It won't be used. Because what this has to do, if you really think about in the background, and I looked at a lot of source code for databases because I'm bored most of the time, it will actually say, well, I'm going to actually transform this thing row by row and then do the operation. Some of this has changed in the very, very, very modern things, or if you use an NoSQL database, all these kind of things, but generally all RDBMSs act the same way with this. This is one of the biggest things. I feel like I built my entire career and I've gotten paid a lot of money by just pointing this out to developers. So if you take anything away from this, left side of the query, if you have a function, don't do that. You got to do something else. And there's different patterns and different strategies on how to solve that. Sometimes you need to, right? Sometimes you're like, well, I only have a 2024. So can I do something like an and or? I'm sorry, not an and or, greater than or less than. And this is really important, and it seems like, oh, that's more code, but it's extremely efficient when you do this. So we're going to apply that fix. We're going to go here. Whoops. So this is what it looks like. And by the way, I built these visualizations because I feel like I spent, again, 20 years of my career talking to developers about SQL and writing good SQL, and it's never really landed until I started showing people what it's actually doing in the background. So if you look here, this is what it's doing. Because you had functions on the left side, it's literally scanning every single row in this 100 records, right? But now, if I was super cool, that's what it's doing. When I remove the predicate on the remove the function on the left side of the predicate and move it to the right, I'm essentially just scanning the records, and I'm actually able to use the indexes in the background. I'll stop there. I'm going to try to ask questions every 2. Does anybody have any questions on that? We'll have time. Cool.
If you were to need to do something like this, and say this is getting complicated. So if you had a big complicated query where the only way to do it is the year transformation, would it potentially be more performant to make like a temp table or a CTE at the top?
Yep. Yeah, so your general idea is like, how can I restructure this query, especially when it comes to OR statements. There's a section on OR statements here. You know, you almost have to restructure your entire query sometimes. Most of the time, though, you can get pretty creative. And you'll do this like weird magic that all the developers will be like, what are you doing? And it's like, well, it runs in a millisecond versus the 10 seconds it took before. Don't worry about it. So yes, you will have to restructure things. Sometimes it's a temp table. Like in Microsoft SQL Server, temp tables are really, really used all the time. And Postgres is a little less. Oracle, don't talk about Oracle. Not a big fan, but I don't know if we're sponsored. But anyways, so yes, you do have to restructure it. Sometimes you have to do different strategies of approaching it. I'm a big fan of CTEs, but I'll give you a warning about CTEs. It's not in here. CTEs are great. They're called common table expressions. Essentially what it means is I'm going to window a piece of data prior to executing the stuff down here. The problem is that CTE the engine doesn't have much knowledge about what that CTE is doing, so it makes a lot of assumptions. As of a couple years ago, I haven't looked recently, but like Microsoft SQL Server, for example, or PostgreSQL would see a CTE and it would assume there's only 10,000 records in there or less. So any kind of, and it would optimize to 10,000 records. So if you have a CTE that's returning back 1 million records, it can be really, really, really slow. So you got to kind of be careful about balancing that. Then you start going into the temp table things. Can I aggregate this data, shrink it down? Can I just do something completely different? Things like that. We'll go back to the query. All right, so we fixed it halfway. So we're 29% faster. This is much better. This is called implicit type conversion. If you look here, not all engines, by the way, do this as bad as this today. So some of the engines, I believe the newest version of Microsoft SQL Server will recognize this and be like, yeah, I don't think that's the case all the time. And basically what this says is, I want to take this string, pretend this is an integer, and I want to take this string here, or I want to turn the integer into a string. And then it does some bad stuff, and it doesn't really know what to do with it, so then it treats it as a string, and then it's comparing against it's basically transforming all of the records on the left to meet a string versus an integer. So it seems pretty innocent, but it's actually a pretty big deal. So we're going to apply that. We're going to here. If you run the query, essentially it's scanning the entire thing. And by the way, it's converting every single one of the records on the left, just like the sargeability thing we talked about before. If you put it on, you don't really have that problem anymore. So always kind of keep in mind if you see a string on the right, it's typically IDs, right? If you see an ID, like a number, and it's wrapped in quotes, just get rid of that. Sometimes it's easier said than done because it's buried in interpolated strings within your Java or your C# or whatever, but you got to kind of just pay attention to actually what's executing. Oops. So cool. So now we are 34.6% faster. We're going to go to the next problem here.
Are you doing this in order of most important?
I'm doing this kind of, no, it's really just a random order of stuff to fix. Whatever kind of made sense from the query perspective is easiest to display. If you look here, I actually put some stats here on how much it saves. So if you want to go to the site and check it out, like if you look here, the biggest one I believe is or. No, this is a little bit of a lie actually. That's probably the worst. I believe, let's see here. Yeah, sargeability is probably the biggest one. And this is probably the biggest one that I keep seeing. And by the way, the question was, am I doing this in order of like badness? Not really, but kind of. In here you can see the general thing. So with anything in a database, it depends. Because sometimes an or statement is the death of you, and sometimes it's not. So it's hard to say that which is the worst. But what I do see the most is select stars, sargeability, and kind of probably this list. This is called a correlated subquery. Does anyone know what that is? If the Oracle people probably know what these are. This is pretty big and common practice in Oracle. So what you're basically doing is you're saying, hey, select count from orders, and I'm saying this is my inner, right, O2, and this is my outer, and I have a bigger part of the query over here, right? That's one way to do it, or you can do it this way, which is basically you are getting, you're subsecting the data, or you're windowing the data so it's easier for it to, you're basically creating a temporary space on a join with just the data that you need, instead of doing a count against all the orders in the outer side. So if we apply this fix, so without it, it's literally running against every single record. It's running that aggregate. But if you do it here, it's only doing it against the aggregate. It's only doing it against the aggregate for the record. It's only doing an aggregate on the records that are within the join itself. So I basically made this small little data set, and then instead of take every record that I have here and then compress and do the aggregation and then return it back. So seems simple, but it's actually quite a large change. All right, cool. So we've gotten, let's go back to our query. We've gotten pretty efficient now. The developers are going to be much happier. Ops team is happier. So we're 50% faster. We're still pretty slow though, because if you remember, it took 6 seconds. Our goal is to get it down to 47 milliseconds. And this is not an exaggeration. This is like, I do this a lot. And a lot of the times we get these massive queries like, oh, we can't optimize it. We need, when I first joined the company I was at, they told me that Postgres was a bad database and we needed to upgrade to Oracle. Upgrade is a funny word. And Postgres can't handle large sets of data. It was a 500 gig database. And I was like, I think something's wrong here. So we started, started inspecting all the queries, and within 6 months, it would happen faster, but we have developers and all the inline SQLs and everything. So we had to, put it into sprints and kind of make a big plan. But within 6 months, we were, 60% faster. The entire website, by the way. So it made an incredible amount of impact by just taking these 10 principles and applying it to our website. So entire website. So our customers were waiting 60% longer, but making these changes in 6 months fixed that. So it was pretty incredible. So this is the scalar subquery in a select. So if you look here, this is the before. We're doing a select max unit price from orders, where, and then I'm doing a select blah, blah, blah. Instead, I'm doing the same pattern where I'm just doing I'm doing this work on a join and getting back a smaller set of data so then I can join to the massive record, to the bigger record set. Instead of basically doing this massive operation against all the data, I'm just being more precise and selecting certain parts of the data and returning that back out to the query. Because if you really think about how a query is running, you're taking data and putting it into certain operators, like I talked about before. We have all these operators. I have like a scan operator. I have a hash join operator that takes two data sets and merges them together. This is kind of this is what it's doing in the background. So we're going to apply that. Go ahead.
So you had a select star, you had a count star in there. Is that going to impact performance, or is it better off doing something like count one?
Oh, the count star question. So the question is it count star or is it count one? So back in the day, when I first started, working on SQL Server back in 2000, and in 2005, count one was the recommended practice, because if you did a star in the background, in the actual engine, it would pass the entire set back and then do a count on that for no reason. Now, since then, in modern RDBMSs, which is a relational database management system, they kind of solved that problem, and the real practice is going back to a count star again, which is still weird to me. Like in all my code, I do select one or count one. So it doesn't really matter anymore, I guess, is the point, because it just someone on the product level on most of these RDBMSs said, hey, it doesn't matter. Why would you ever return back that the entire data set back to do a count? It doesn't really make sense. So we'll go in here. Oops. So if you look here, because of the way we formatted the query, we actually executed 20 different queries within itself. When I don't do that, I run one query and then pass it back on the outside of the query. So it's much more efficient to be able to just do that instead of running these 20 queries over and over again. And by the way, when you're going about this and you're looking at these problems, so hopefully you go back to your desk or whatever and you see these, the best way to do is go into your AWS console or whatever consoles you have, whatever tooling you have, and say, give me the worst performing queries that are greater than 10, right? Because the worst performing queries that run less than 10 times are probably just some ad hoc thing or some report you don't care about. What you really care about is how many times it's happening. So if I have a query that takes 1 second, it's run 1,000,000 times a day, that's more important than the query that takes 20 seconds that's run 10 times a day. So if I find that 1 second query, I'm like, that's not good. I want to get that down to 1/10 of that, or even 100th of that. So you may find one of these things just dramatically trips it, and it's like, okay, it's wicked fast now, I'm good, I can move on. And then you can leave the other things in there if you want, or you can refactor the whole thing. I tend to just try to surgically apply these changes where it matters. So I may not go through an entire query and apply every single one of these, because it's a large refactor. There is some risk, because I've been doing it for a long time and I still make mistakes. Like, I'll apply something like this where and then I didn't think about something properly, and it just changes the result set entirely. So you got to be a little careful. So I'm pretty precise and surgical on the way I approach these things. So super cool. We got, how fast are we now? We're 69.9% faster. This is incredible. We're doing great. So now we're going to go into select distinct, right? Does anybody do distinct here? Do you just slap a distinct on there because, hey, why not? I know so many developers that do. They're like, well, what if there's a duplicate, right? I like the theory, but the problem is, if you're running a distinct, there's typically, and there can be duplicates. The way you're approaching the query might be a bit off. And you may want to rethink how you're approaching the query itself to make sure that never happens. Your join patterns, your subquery patterns, your CTEs, and all that kind of stuff. So you want to be a little careful about that. And I'll show you why doing that works. why that's such a big deal here. So if you run a select distinct, if you look what it did, I'll do this again here. I have the distinct on, so it selects all the rows. Just so if you think about like your college days when you had to do distinct in an ordered set, or you're doing some leak code thing, or you're on some interview, like how do you make a distinct set of data? Like what are you doing, right? You're taking the data, you're looping through it, and you're saying, okay, well I see A, right? Let's say you have a list of alpha characters. I see A, I'm going to take it, put it over here, and keep going, I see another A, I can skip that. And you keep going through, and you're building the list. And it's an expensive operation, especially when you're dealing with hundreds of thousands of records, millions of records, billions of records. But if you don't have a distinct, it doesn't do that, right? It doesn't have to try to go through and take the entire thing and make it distinct. So your best practice in this case is to reformat your query almost entirely to make sure it doesn't do that, or approach the query differently to make sure that the distincts can't happen based on the schema. Does that make sense? This one kind of trips a lot of people up. Go ahead.
I've seen some developers, instead of using distinct when they get duplicates, they would use group by instead. Do you think that's any different?
So the question is, well, if we, instead of using distinct, can we just use group by? It's more code, and it does essentially the same thing in the background. When you really look, if you took a distinct and then you did a group by, and you actually pull out the query plans, unfortunately I don't have one up, I wish I did, they would essentially be identical, because the engines are smart enough to see what is the landscape of this query, how am I going to build this query plan? You'd probably have a similar query plan. It would do the same thing. Because a group by still has to say, well, I need for my grouping objects, I need to then do that same thing I talked about, right? So distinct, group by, relatively the same performance. The problem with distinct, that's like, when someone comes to me with a bad query, or I'm looking through all of our logs and saying like, well, these are the slow ones, that's the first thing, it's at the top. It's typically the distinct, so. That's a good question though. All right, so we're doing super good. We're much faster. We're 78.4% faster. Does anybody use or statements in their queries? What's the reason you would do that for?
So like this one works because it's the same field, but I have one that I'm working on right now that I didn't write. I'm working on it.
Everybody says, I swear, whenever I go to any meeting, I'm like, I didn't write this, but this is really bad. I'm the bad guy in my company, because I got to go to I have 100 developers, so I'm the main data architect for our company, and I have to go to all the developers and be like, this is bad, guys. But go ahead.
So the one that I'm thinking of right now that I was just doing analysis of is this field is this, or this other field.
This other field, and you probably have a predicate. You probably have a function on the left side, so it's not sargeable as well too. So it's probably double as bad. How do you solve that? In this case, this is a very simple example, so I could fit it into like a relatively small thing. The only solution to that, and by the way, this goes to Snowflake, this goes to pretty much every system, or statements are the killer. And I'm kind of shocked they haven't, like most RDBMSs haven't figured this out yet, but in most cases, you're gonna actually have to write 2 queries entirely, and then do a union between the 2. So it sounds crazy. But I'm going to say something about union and union all. But in that case, if you have this one query like this big that has an or statement at the bottom, I'm guaranteeing, if it's a large size database, I'm guaranteeing you it's going to run like crap, and it's not going to hit any indexes, because it doesn't know how to approach the query appropriately.
Because that's actually something I was, with this particular query, we have, it's a tax thing, different states have different things that they need to do, so you've got this big complicated thing at the end. You can do what you said, you can have every state has its own different logic flow, but then you identical other than that one line, you suddenly have, but what if we forget to update one of the 7 identical SQL statements we've got out there that only have this clause out the bottom different? Do you have any strategies for a better way to maintain that code base?
So there's 2 ways to do it. You could formulate your data so you could have a temporary table or a CTE above that gets the records that you care about, right? Or you could have 2 CTEs that identify the records, and then you join, and then you have a common join pattern between the 2. Like, let's say you have a customer, right? I want to know all customers that live in Kansas, and I want to know all who have orders above 100, right? Or above 100 things, right? So you have kind of 2 weird things. You might want to take both of those and put them into 2 different lists, right? And then join that list together, and then your main query stays the same. You just join to that one thing. So you still have that. You still have cohesion, right?
Yeah.
Does that kind of make sense?
Yeah.
So the question is, how do you maintain the code, right? Because it gets unwieldy. Sometimes you have 7 queries. And I've seen, I worked on one recently where it was a very large batch system. It takes hours to run, and there's OR statements all over, the code I inherited. So that was one of the main problems I had. It's this much code, but it runs literally 97% faster. So it was the trade-off we had to take to make this thing faster. I mean, we spent days staring at this, trying to come up with different solutions. The previous solution I talked about didn't work for us, so we actually had to do a union between the 2 data sets. And it screamed at that point. So, a quick note on union and union all. I have one gift, by the way. I gave my other gift to the facilitator. Who can tell me the difference between a union and a union all? Who said that? I'm going to try to throw this. If I hit someone, I'm not liable. This is recorded. Shit. I'm sorry, it probably broke. Can you put it back together and hand it over? It's a fidget clicky toy. I have a 3D printer that I'm constantly trying to justify to my wife because I spent over $1,000 on it, and so I'm printing things all the time and giving them away. I need it for conferences. I need to, give out things to the audience. So it's the coolest toy ever. So it's got brown keyboard switches in it, and it's just a clicky toy. It's the funnest thing ever. If you work in an office, you'll annoy everybody, and I love that. Did you get it? Is it all back together? Cool. All right, so that was the OR kill. So let me show you here. Let's go into the thing. Right? So in this case, we have an OR. So it does this or this. It's literally doing a full table scan because it can't do anything else. And it'll sit there and go this way, and then I got to go search for these things. And it's just, you look at these query plans. I'm going to try to, I'll pull it up on Google actually in a second and try to show you all a query plan if you haven't seen one. But it's basically an upside down tree to say this is where it started, and these are all the operators that took, and then it had to pass all the data back up. And they get pretty wild. But in this case, it literally doesn't have to do anything. It can do a seek instead when you kind of reformat that. Let's see here. And by the way, I made this website so like you can kind of use it as a tool. Again, I don't make any money on this. I don't track any analytics or anything. It's just like, I've talked to so many people over the years about these query problems. I was like, I'm just gonna make a tool that everybody can use. There's no reason. I think I might be one of the few people in the world that don't want to make leads or anything on this stuff. Yeah, go ahead.
Or when you're trying to figure out like those complicated ones where you've got a couple of, the union versus the OR and all that stuff. What is a good way to find out how performant it is while you're trying to develop it? You can just run each one and see how long it takes, but then also you don't get the idea of like the scalability as we get more and more data. So what's the best way to know if so say we're taking the example that I have where we have a couple of different states, it's like, okay, maybe we do that temp table at the top and then do the conditions at the bottom with that final thing versus like maybe we have to do all the unions. What's the best way to try to figure out?
Okay, so how do you approach, if I should be over performance tuning this thing or not, or how can I just slap some code together? Essentially is what your question is, right? it becomes a dark art. And this is why AI isn't good at it yet, because there's so much to it, right? It's, AI doesn't have the context. I'm a big AI programmer, right? Agentic programmer, vibe coder, whatever you want to call it, right? And that's mainly what I do. And I've realized for SQL queries especially, if you can't give it the context of this is going to grow in the next 5 years, and this is what our growth rate is, it can't write a good query, right? So you, in your background of your head, probably know just by intuition that we're growing at this rate, we're doing this, they're probably going to get more customers, and I know this other project's going to come down where we're going to stick a bunch more customers, we're going to merge these systems. So then you start saying, well, I have to make sure I preemptively do this. So that's really the biggest key. I had another talk here in the same room, I think, actually, last year. It was talking about when do you scale past SQL Server. And one of the things I put out there is the best way to approach any schema change or any data thing, right? I'm a data architect. So whenever a developer comes to me and proposes, hey, we want to do this table solution or anything, we kind of back of the napkin math it out, right? Well, how many records are going to be in there? Well, it's for customers. Okay, cool. Our company is going through a 20% growth rate every year. So we have 100,000 customers today. So in the next 5 years, what's that going to be? That's going to be 100,000. Is the math right? It's going to be 100,000. Oh, I'm sorry, a million. Over a million customers. So I might want to say, yeah, we need to make sure these queries against us are very performant. I worked on a system where we had to track every single ticker for every single account and the value it was per each day for different weird combinations of clients and stuff like that. And when the developers started proposing the solution, I was like, well, let's do the math, guys. And it ended up being hundreds of billions of records. So we took a way different strategy to approaching it versus just the one big table, right? Do you use partitioning? Do you use a non-SQL solution? Do you use all these other things? So if you take anything away from my little small rant there, you really need to project out how much data is going to be in this thing. Because that's probably the number one thing that I do when I first start looking at new solutions and new tables. And this just means you have to be more in tune with the projects that are coming down the pipeline and how fast your company's growing, all these kind of things, or how fast the system's growing. That's just an interesting point, by the way. Our jobs 10 years ago used to be, I get a project, I build the thing, move on. Our jobs now, we actually have to be much more in tune with our business and understand these things. And it's so important to understand, because otherwise you're just building software within a silo. You might as well just be an AI. The reason that AI hasn't taken our roles yet is because we have all this context and we can have all this critical thinking outside of just, I got to build a table to do something. So, very large rant, but did I answer the question? By the way, in jest, I say AI is going to take our jobs. I work on AI strategy for my company, and I do it all day, and I don't think it's happening. So I'm actually not a believer that it is. I think it's going to, there's a thing called someone's law, I forget what it is, where our job's going to be exponentially harder, and we're going to need more and more people doing development. So this is a not in with nulls. This is a little controversial because I know some RDBMSs handle this well and some don't. Postgres, the version of Postgres I was working on a while ago did not handle this well, but I believe SQL Server might. But essentially this is saying customer ID not in, select customer ID from customers where status is inactive. What if one of those customer IDs is null? So in this case, a not exists. This is why this operator exists. So it's saying, I want to make sure it not exists, because a null can invalidate the entire result set and says, oh, nothing's there. And I'll show you here. So I'm not like pretty stringent on this one, but I do kind of keep this in mind when I'm going about this. So if you look here, I have two unknowns, I have two nulls. And it will not return back anything. If you look here, so it actually the in statement would actually return a null because it had a null in the return. If that does that make sense? So the better way to do it would be to do a not exist. I want to make sure this condition doesn't exist, and then it doesn't have that problem, even if there are nulls within the data set. How are we doing on time? We got 20 minutes left? 15? I think 15. All right, we're almost there. So now that we've applied all this really fun stuff, we have no index. I'm pretty sure we all know this no index one. By the way, we're 89% faster. So this is basically just not using an index. An index I'll give a quick explanation of what an index does. There are different types of indexes all over, but basically the main one is a B tree that basically segments the data so that it doesn't have to do an entire scan. So if I have a customer database of 100,000 customers and I'm saying where first name equals Tristan, right? If I had an index on there, it would basically make a tree, an upside down tree, to say and segment out. So that way it can say like, go left or go right. Okay, go left or right, go left or right, go left or right. And it only has to do so many operations versus scanning everything for Tristan. So we'll apply that fix, go into here. So again, it's literally searching for everything. If I had an index on there, it's using a tree and it found my record almost immediately. So this is something that I want to point out a couple different things about indexes. Indexes are interesting because you could over-index a table, and this is where I believe that putting your data architect hat on, we're all, I believe, have somewhat of a role into this, even if you're just a developer or if you're a product owner, it doesn't matter. You have to kind of understand the frequency and the usage patterns and the query patterns on the tables themselves. So if I have a customer table that's getting updated 100,000 times a day, putting 100 indexes on that is pretty expensive because what it has to do is it has to go through and maintain that index. If I update first name and I have an index on first name, it'll have to go through that index and say, well, I'm going to update the main record, plus I have to update the index. So it doubles the effort on the updates. But if you have a very low, if you are very small or low update pattern or CRUD operations essentially on the table itself, you can slap a ton of indexes and it's not that big of a deal. So if you have like a domain table or something like that, or a lookup table, slapping a bunch of indexes really isn't that big of a deal because they're small, it's quick, it's fast, and you're never updating it. So the engine doesn't have to maintain that index all the time. Has anybody seen a table with 50 columns, but 30, 40, 50 indexes? I've seen it before, and it's crazy because they're like, well, why is this thing so slow to work? And it's like, well, let's just delete all the indexes. Or you find out what the main query patterns are, you look at the logs, and you can kind of get a general consensus of this is like 90% of the queries, and we're just gonna tune the indexes to this. Or we're going to make sure we're going to go through, and most of the RDBMSs like SQL Server, Postgres, they have missing index queries or unused index stats, where you can look at the system tables and say this index has never been used, and you can just kind of almost blindly delete it, assuming that your stats have been not wiped out in a large period of time, like a week or two. Be careful with that one, by the way. You might want to look at stats over the course of 45 days because, or if you're a financial services company, 90 days to 120 days because you have these seasonalities of queries. So sometimes at the end of the month, you may run a ton of queries, right? And that's where all the indexes were there for. And but if you don't have that problem, if it's consistent throughout all the year, the query patterns, you can kind of blindly do those things in a sense. I'd say blindly, it's a bad word to say, but. And then we have, so at this point, we are 99.3 faster. This is the one that I see bites most of us. I have an order by with no limit. Limits are really important because Today it works fine, tomorrow it won't. Because as you get bigger and bigger and bigger and bigger, your query results are going to get bigger. So if you were developing an application, you wouldn't want and let's say you have an application that shows the top 100 most recent orders for a customer. You wouldn't want to return back 101 records or 1,000 records and throw the other ones on the floor. So you typically try to say, well, I'm serving this to the customer or to the client, to the service, whatever it is, and I only need this many. So a limit is really good in that case. And then if you need there's another option called an offset, which will give you a ability to do pagination, which is like I want rows records 100 to 200, 200 to 300, et cetera, et cetera. So. And the reason that's important is because data grows, and data grows fast. The funniest thing about databases is it's a living, breathing thing. Application code is pretty static in a lot of ways, unless you're calling a bunch of APIs. But databases are really kind of a weird beast where it's going to change just throughout, and it's going to grow with you in the organization, and you're going to buy a company, and you're going to merge two systems together, and it's going to be double one day. So limits are really important to add to your queries to make sure you're not just doing bad things. Good.
Now, I might be outdated here, but when you do a limit offset, it still has to retrieve the entire result and kind of just get the offset that you want.
So there's a couple different patterns that it uses to my knowledge. One, it'll get the largest. So for example, it'll go from, so for example, if you're doing a pagination from 5 sets, from 100 to 200, 200 to 300, et cetera, and your offset, when your query offset is at 500, it'll get 100 to 500, and this could be the last bit, right? I've seen, and I'm pretty sure, I could be wrong, I'll have to go Google this afterwards or AI it now, but I'm pretty sure it knows in the background, the data is stored in a very particular way where it can, if it's indexed properly and it's a clustered index, it knows the offset on the actual extent itself. So the way data is stored, right, they're all stored in these small little blocks called extents. And those extents have many records. Sometimes it's one, sometimes it's like a bunch. And there's statistics on each one of those extents to say, hey, this is the main ID, et cetera, et cetera. So it can use a lot of the statistics to kind of manage that. So the question was, when you're doing an offset, is it just getting all the data anyways? It kind of is in some cases, and again, it depends on the RDBMS. There's so many out there. There's PostgreSQL and all that stuff. So I found that Microsoft SQL. I traditionally used SQL Server, Microsoft SQL Server for a long time. I found that they had a really good optimizer and handled a lot of the things like this. I'm using Postgres primarily now, and unfortunately a little bit of Oracle, which I don't want to talk about. But they all kind of have their own little quirks, so that may be true for one but not the other. So, but I wanted to kind of show a simulation, right? Year 1, year 2, year 3, year 4, and I've seen this, right? I have a system now that's growing at an exponential rate. It's incredible, and it is really, 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 really hard to maintain some of the bad decisions that we made, right? So if you look here, if you didn't put a limit on this and you're just returning back everything, and your queries will start running slow, year 2, year 3, you're pulling back just an incredible amount of data and then just dropping it on the floor. So, and now, so where did we start? We started at 327 milliseconds. That's 6.3 seconds, which is incredibly amount especially for a user website. If it's not a report. Most users get frustrated after about 2 seconds. But now we're down to 47 milliseconds. I've done this more times than I can count, and it seems like magic. For 20 years or so, I've just been telling developers the same 10 things. That's why I built this website. Most of it is this stuff, right? Sometimes it gets to the point where it's like, oh, I need to restructure this thing. I need to change schema. The far majority of times that I've seen, you just need to change your query and approach the query a bit different. a couple different tiers. Sometimes it's a quick fix, sometimes it's a restructuring the query, sometimes it's restructuring the schema. So that's kind of the thing. So where are we at on time? We got 5 minutes?
We're at time.
Oh, we're at time.
We're at time.
Hey, before, what?
What is the website?
It's SQLcaffeine.com. So again, make no money on it. It's just to help the community because I love everybody here. I just wanted to say before I end, I want to thank you from the bottom of my heart for being here and allowing me to do this, and thanking Stir Trek. So thank you all so much. I really, really, really do appreciate you being here. So thank you.